Graphics processing units, GPUs, have revolutionized the way we perceive and interact with digital media, from watching videos and playing games to designing and rendering complex 3D models. There are two main types: integrated GPUs, iGPUs, and dedicated GPUs, dGPUs. An iGPU is a GPU that is built into the same chip as the CPU, central processing unit, on a computer's motherboard. It is designed to handle basic graphics tasks, such as displaying images, videos, and basic animations, and can be found in most modern CPUs. An iGPU shares the system memory with the CPU, which means that it uses a portion of the RAM, random access memory, to store its video data. iGPUs are generally less powerful than dGPUs but are more power efficient and can save energy. On the other hand, a dGPU is a separate graphics card that is installed in a computer system to handle more complex graphics tasks. Unlike iGPUs, dGPUs have their memory and processing power, which means that they can perform more demanding tasks such as high-end gaming, 3D modeling, video editing, and other graphics-intensive applications. dGPUs are more powerful than iGPUs and are equipped with dedicated hardware designed specifically for rendering graphics. Choosing between iGPU and dGPU depends on the intended use of the computer system. If the computer is mainly used for basic tasks such as browsing the web, watching videos, and working with office applications, then an iGPU is sufficient. An iGPU is also suitable for casual gaming and light photo and video editing. However, if the computer is used for gaming, 3D modeling, or video editing, then a dGPU is recommended for better performance. dGPUs offer better frame rates, higher resolutions, and more realistic graphics than iGPUs. When it comes to gaming, dGPUs are the best option as they can handle the high-end graphics of modern games. dGPUs are equipped with high-speed memory, faster clock speeds, and more processing cores than iGPUs, making them capable of handling the most demanding games. In contrast, iGPUs may struggle to run games at high resolutions or frame rates. For content creators, a dGPU is necessary for video editing, rendering 3D models, and working with graphic design software. dGPUs offer faster rendering times, smoother playback, and more advanced effects than iGPUs. Content creation software such as Adobe Premiere Pro, Maya, and Blender all require a dGPU to run efficiently. In terms of power consumption, iGPUs are more power efficient than dGPUs. Since iGPUs use system memory instead of dedicated memory, they consume less power than dGPUs. iGPUs also have a lower thermal design power, TDP, than dGPUs, which means that they generate less heat and require less cooling. However, this energy efficiency comes at the cost of performance, as iGPUs are not as powerful as dGPUs. Another factor to consider is the cost. iGPUs are included in the cost of the CPU and do not require any additional expense, making them a cost-effective option for basic computing needs. In contrast, dGPUs can be expensive, with high-end models costing several $100s. However, for gamers and content creators who require high performance and advanced graphics capabilities, a dGPU is an essential investment. In conclusion, both iGPUs and dGPUs have their unique features and benefits, making them suitable for different types of computer usage. Choosing the right GPU depends on your intended use, budget, and performance requirements.